Okay, we are live. This is definitely the first time we're doing this intro. Ignore any previous clips to the contrary. Those are AI generated. This is going to be the start of the Puffer 5 dev sprint. I think that in less than 2 weeks, we can get the core algorithmic component done for this update. The specific method that we're going to be investigating here is very high confidence because the type of problem that it addresses, it seems that fundamentally you can't really address it in any other way. To give you a sort of a quick example of the problem, let's say you have a 2-hour task. You get reset every time you fail it. Every single time you make a mistake at the end, you have to redo the whole thing. So it's very, very inefficient. This is true in the real world as well, but in Sim, we can shortcut this. And this is likely to give us a massive, massive boost to the convergence speed of our algorithm. I will go over the detailed version of this in a moment. We do have that. A couple things about the way that I have set this up, because I figured I would have some fun with this research sprint and also set it up to be as productive as I possibly can. Y'all can join me on this plan if you're game. Morning starts with a 10K run, followed by some quick compound weightlifting, or some quick compound weights, not Olympic lifts. Followed by quick breakfast, followed by most likely a 7 to 8 hour stream. And then dinner thereafter, and retired early for the evening to do it again. And very little otherwise going on. So hopefully this will put me in a good mental spot to make good decisions on the algorithm choices. I think the overall algorithm is pretty well set up, but there are some specific choices that, making them sooner rather than later and getting details correct will save a ton of time and allow us to do this quite soon. Go over to the stream view here. Hey, Anish. That's good to hear, man. That's good to hear. I'm glad you're doing better. Welcome to the 5 stream. Okay, let me go over the algorithm plan first a little bit. I wrote this. I basically just had Codex, I asked, hey, is there anything unclear here? And then I just went and fixed everything until it was clear. So, but I wrote this. And there are a few new hyperparameters. There's an additional prioritized replay buffer. There's a warm-up time. There's the fraction of environments that are going to be using this new curriculum learning method. And then there's a buffer of states of a fixed size. You're going to need this ring buffer for states. You're going to need a buffer for advantages, and you're going to need an index buffer. The way that the algorithm works is the first time you do rollouts, or the first time step every time you do rollouts, if the warm-up buffer isn't full yet, then you're going to put all of those initial states into the buffer. But once it is full, you're only going to put a certain fraction of the environment states into the buffer. And the rest of them are going to have their states set using prioritized experience replay sampling over the existing state buffer. So you have a bunch of previously recorded states, you're going to sample from them, and you're going to sample ones more often that have high absolute advantage estimate. So these should be high information states. During training, you compute your advantage across all the segments. This is going to be used to update the priority of the buffer. And you are going to sample segments from the current data buffer. This is basically exactly as before. It still uses prioritized replay, but it's a different prioritized replay buffer. And we're going to also make sure that this is compatible with Puffer 4 if you just set one of the hypers to 0. We're going to do this on mazes. I've already ported mazes to be state settable and tested that it trains correctly under Puffer 4. Keep everything deterministic. We're going to ignore multi-agent for now because it's a pain in the ass. Running in weights will not be streamed as well. I do not have a practical way to do that, and also I need some damn time to myself. But, I'm in Palo Alto doing that whole thing. I guess I can share the Strava or whatever if you all really want me to. It's a really nice hilly course, though, as well. It's got, like, I think 700 feet elevation gain for the course, maybe? For the 10K. Okay, so this is the basic of it. Because everybody always asks me about the damn language models, even when I'm, like, trying to focus on cool stuff. I'm going to address that now, and then I'm just going to refer people towards the start of this stream, rough timestamp, whatever this is. 5 minutes into this stream, 6 minutes into this stream. All right? We are going to be using codecs for this. We're not going to be vibe coding shit like a moron. I'm starting with this precise spec. I'm going to be editing this. This was generated based on the algorithm description that I wrote. I'm going to be editing this a whole bunch, both manually and with codecs at a high level, until I have every single variable, allocation, function, kernel, etc. nicely how I want it. And then I'm going to have it implement this in very small, isolated changes that I'm going to be reviewing manually and editing as well to make sure it doesn't make a mess of our nice code base. And this is also why I am quite awake today, because I want to make sure that I don't get lazy with this. Yes, Tim. So we're storing raw state. The state is not used as the heuristic for selection. That will be advantage. So you have a one-dimensional advantage estimate. You don't need any downsampling. You don't need any heuristics. That is the key difference from Go Explore. And you are storing the raw state because that is how you set the state back to a specific thing. So unlike Go Explore, we're not going to rely on deterministic resets and then stepping all the way back to whatever state we want to set. That's incredibly inefficient. We are instead going to be relying on setting directly to the target state. And the key realization of this is that we can always make our sims this way because we're writing our high-perf sims ourselves anyways. Okay, I will share the Strava, but I think I will share the Strava after the 2 weeks. If you all remind me, because I don't want to, like, leak my live location, basically. All right, so let's start now. We're good? I think we're good. Train hyperparameters. This is fine. What is no prioritization? $250 is nuts. Yeah, we're doing, this is going to be 60 kilometers per week starting, and probably will ramp up a little bit up to maybe like 70 or 80 by the end. Size T, state size. Can this be made available static? I don't think it actually can it? No, it can't be, right? I think it has to be void star. We'll figure out maybe we can make it static later, but that's kind of tricky. Manuel, this will be the first time of many, I'm sure, for the stream. Refer you to about 6 minutes into the start. I addressed code tools, and I'm just going to refer everybody to that. It's just a little bit of lifting, Tim. I mean, I'm also... Oh, yeah, I forgot the part where this is also on, like, 1,000+ calorie cut. So the lifting is basically just to make sure I'm maintaining strength. It's basically like, reasonably light breakfast, light dinner, no lunch. I already have the algorithm skeleton, Jess. Like, the algorithm is already well defined. This is now implementation level. If people keep asking, I'll add some text. Again, 6 minutes into the stream. I explained this at the start. Like, you'll basically see from the work how I'm using stuff. This is not going to be vibe-coded bullshit. Reuse existing prio buffer. I believe we can do that. There are several uncertainties in the core algorithm liberty. This is brand new research. So the biggest challenge is going to be making sure that if stuff doesn't work, like isolating implementation bugs versus problems with algorithm, which is why we need very high confidence env tests. Yes, this is based for Puffer 5. I think that this thing is going to be powerful enough to solve about half of the remaining problems in the field. It will require that you have a custom sim to take full advantage of it, and that your sim be written in a certain way, but it's in a way that is amenable to very high perf and not very complicated. We will have to refactor every single Envin puffer a little bit to accommodate this, so obviously we're going to only do that if this is like really solid. There will also be a fallback mode that will essentially just run the puffer 4 algorithm, and that will fail. That will be handled gracefully. Is this type going to be available? Tim, it's the idea is the key insight from Go Explore is the amount of improvement that you can get from using state sets. The specific sampling mechanism is going to be a lot closer to what we have currently in Puffer, and then we're also going to be using advantage as this signal of information. Is there pseudocode somewhere of the idea? No, you can go back a few minutes in the stream though. I explained like the base algorithm. This is a new algorithm. We're not implementing anything existing. Oh, nice, Jess. He does have conf changes. Like, I don't know if I've merged them. He does have conf changes. There should be a PR open. I might have merged it. I forget. Do I use size T and stuff? I don't. Go puff. How about go puff? Register state buffer. Fill state ins. Decent so far. We should probably... Yeah, we should probably pull... We should probably pull this in, right? This gives us a fresh slate. Okay. Fresh state advantage. Okay. These are the main changes I found. Hello, man. Still not sure with these kernels if we need all of this. I mean, this will be the main thing we'll have to figure. The good news is this is not very many. I think this is just a copy. We can probably make this into a more generic scatter if we need to. Let me think of the order of operations here. I think we do env and vec changes first. We'll see if we'll do the vec changes first, and then we'll do the allocations, and then we'll do the buffer, like the algo changes. So basically, this shouldn't break anything at all until we start getting into the actual like final bits, which should only be a couple hundred lines of code, I would think. Maybe a little bit more. Yeah, I've gotten a lot better with my time estimates on stuff though, Tim. Like, okay, Puffer 5 took 50% longer than I anticipated, but we did like more than double what was planned in that update originally. I mean, Puffer 4, yeah. Puffer 5 is going to be hopefully quick update. Well, to be fair, we did most of what was going to be Puffer 6 in Puffer 4. So now it's like 5 is intended to be a much shorter update that's focused on a small set of algorithmic changes and some cleanup. It's a heck of a lot more than SB3 and OpenAI Gym. So SB3 is a bunch of algorithms implemented in a really bloated, slow way, and they're standard algorithms. This is state of the art, our algorithm based on our latest research with comprehensive backing and evidence in the shortest, simplest, fastest way possible. OpenAI Gym is a big, heavy, bloated API for environments that also includes threading and vectorization, but it's really crappy and slow. In our case, we have a whole bunch of environments with a very, very minimal interface, no big bloated API, and a simple, fast vectorization backend, all designed from the ground up. And it's all open source. We have tons of environments from contributors. We build our own. We do our own custom research. We come up with our own custom architecture work. We do pretty much everything. Now, this is not Codex Watch Party. This is... I mean, does anybody know how to fix this stupid, like, sandbox fail thingy? Okay, I guess it works. Four was intended to be a much smaller, not replace Torch. Like, it was intended to just be Torch C++ with a few custom kernels, possibly the new architecture, but also possibly just like bfloat 16 LSTM support. And like really not that much else. The goal was only 10 mil steps per second, and we ended up hitting 20 million with full custom everything, only 1,000 lines more code than the Torch version was going to end up being, and the new Soda architecture. Hey, Convert. Oops. It's not every problem. Like, it's not a good choice for stuff that has strong language and vision priors in particular. But I do think it's going to be very useful in core scientific progress, including in biological applications. And that's actually one of my main interests. I'm not going too deep into anything like any of the really tough applications just yet, because I kind of want to get reinforcement learning to a state where this is like really stable, solid, consistent tech first. and I think we're less than a year away from being there where we can actually do this stuff. What's next improvement once this works? There are a couple other exploration type problems, Tim, that I don't think this will fully solve. If you don't get reward, Jess, this is dependent on you getting reward. So this will help you latch on to reward much more quickly when you get it. Um, and to like chain together rewards much better. But uh, it doesn't solve like state coverage. Mm. Yeah, I noticed this. C++ is kind of just shit. Okay. That problem is not really an RL problem. That's like a human-like pattern recognition thing. Like, the interactivity that they have is very, like, minor in comparison to the pattern recognition crap. No, it will help Sokoban, Tim. It just won't help, like, one gigantic Sokoban level that you never solve randomly. Like, it'll help, I think, when you have, on the current version where you still have the curriculum of levels, it'll help. It should be a substantially more powerful version of the implicit curriculum that we have here. Yeah, this compilation unit crap's very annoying. I think ultimately we're probably going to have to get stuff to be a single compilation unit, which is annoying because, like, it'll force us to make the code valid C++ as well as valid C, which is kind of annoying, but it does fix a lot of jank. I'm pretty bearish on a lot of the world model stuff, frankly. Like, one of the main papers in that space is basically just fraud. But I will say that world models from supervised data, that makes sense. But world models, like, end-to-end with RL, is way sketchier. Oof. So this is just the end side stuff, and I'm not super happy with this. But I think that the stuff that I'm not happy about, um, the stuff I'm not happy about essentially comes down to the way that we have compilation structured. I know that already creates some dumb things. It's quite possible that in the future we do one compilation unit, or we have instead of having like the end be the extra compilation unit, we do the core of it, including the env and the algo as the main thing. And then if we have some kernels that take a while to compile different versions, we do that as a separate unit. All right, this is a relatively nice small change. Okay, let's take a look. So we're just finding state. Kind of gross here. Yeah, I don't like the fact that we have all these helpers. I think this is the type of thing where this amount of jank will convince me ultimately to do this as a single compilation unit, provided there's not a big perf penalty. Yeah, because see, there's no other way. There's no way to make this a single compilation unit otherwise without changing and complicating the environment spec. Yeah. Okay. What do you mean by compilation unit? So right now you compile the env separately, and then you compile training, and training statically links the env that you already compiled. This creates a little bit of jank with types, particularly if you have header-only style implementations, where the actual core logic is in the header file. So, I mean, the options would be either we would have to split the puffer envs to have a separate header file for types. I hate that. Or we have to compile the whole thing with NVCC, which means C++ and C compatible code, which is a little bit annoying. Or we just have to deal with a whole bunch of jank in between those two layers. Great. I have to real quick start the Docker, restart the Docker. I'm going to use the restroom while this restarts. Yeah, I'll be right back. Okay. There is a chair, but it's getting green screened out. Hey, that guy. Yeah, you don't do jank now, solve that later without at least some reasonable understanding of stuff, Tim. Like, at least here, so the decision I'm making now is, this is going to be jank. Now, I have a solution to this later. I already know how to solve it, but it is going to require a larger refactor of things that I don't want to touch now, because if I touch them now, I risk the stability of the experiments that I want to run for this version. This should be stable even though it's bloated. We'll do this. If it works, then we'll do the other refactor. Still, we just started it, man. We just started it. This is the first week. Plan is to do a 2-week sprint on this. Okay, we still have stable, what looks like stable maze training. We're going to make sure that this is still stable. Curriculum would be a nice name for a CUDA library. I don't really need a CUDA library for this. I prefer riculum.cu. Since it uses ring buffers. Okay, this is getting quite close. We got 97% here, 98%. Just leave it 99.2% is where this run caps out. Okay. Basic ass scatter kernel. Is this still deterministic? Okay. Cool. We didn't break anything with this so far. This is still running nicely. 7-minute test is a little unfortunate, but not too bad, since we shouldn't have to do too many of these. We have no expectations about the perf of these kernels. I just wanted it to be not a massive amount of code, at least. And we can get some experiments done, and then a lot of stuff we can re-architect. A lot of stuff we can re-architect. See, this is the type of thing where I need to learn more CUDA, because I should be able to see this pattern, like this I should be able to review way better and write this myself much more easily. I understand this more than before, because I did that day of... What are we loading into shared memory here? The local sum? This is probably for the norm, right? The shared norm? Yeah. I think that's it. Now, this should be a very small diff. if I've done this correctly. Like, this should be a very small diff. There's one little bit I didn't fully plan with just some indexing on train that might bite me now, but other than that, I think everything is pretty sane. Yeah. Because everything is synchronized at the start of eval. You don't have any weird race crap there. And then we're going to have to start thinking about the test env in a moment here. It is quite possible that the version of mazes that I have at the moment is not a good test environment. Mazes as a whole, we will be able to construct a very good test environment out of them. That I am positive. But it is possible that the default one is not very good. Hello, Joseph. What are you working on today? This is the start of Puffer 5 development. This is going to be a state set based curriculum learning method. I'm expecting a generational leap in performance, at least for a large class of environments. And it shouldn't take very long. I have 2 weeks planned for this whole update. Or not this whole update, but for I'd say at least single agent results to be very clean and stable. It's possible we do it much more quickly than that. It's possible that things get more complicated and it doesn't work fully in 2 weeks. We will see. But I think it's very likely that we exceed expectations here. Yes, multi-agent is very annoying for this, Jess. I think this doesn't work at all with, like, massively multi-agent M's, like, ton of agent M's. I think it does work for few agent M's just fine, but there's some infra associated with it, kind of similar to how there is for self-play. Okay, I have to not autopilot here. This is important to do this correctly. Yes, it will work with self-play, Jess. Okay, let's look at this diff. 115 lines. Wait. Uh, Not huge fan of the way this is done. Can I work with this? I think if we keep this diff small, I can keep this because I'll be able to refactor all this stuff today. I mostly just need these things to not make dumb mistakes that take me time to find, Jess, because like I'm taking ownership over the full design and the code quality and everything anyways. This is defensive and I don't like this, but we'll leave this for now because I don't know how big this is. That's better. A little bit better. Little messy, not terrible. Still, I think this will end up being a total like 400 line diff, if I'm correct. Yep, that's the same diff. Kind of defensive. It's fine, Jess, because if it makes stupid errors, those will catch it during dev, and we can just remove the defensive stuff after. Also, this is almost done already. We've been live for an hour 20. Here are the new hypers. These go in default, yes. You need to have fresh ends. Limitations for PPO. Well, I mean, there are a lot of them, but they're kind of the same limitations as all the other major algorithms. If you want, like, versus off-pol or whatever, I have an article on that. The problem is that a lot of the limitations that people attempt to address, like, they don't even define the thing that they're trying to fix well, in a way that's consistent. Wanting to end with 10k steps. Wanting to end with 10k steps. Oh. Yeah, you're just not gonna solve stuff in 10k steps. That's not how it works. They're too long. Yeah, X truncates stuff sometimes. Like, if you type a bunch of messages back to back, sometimes stuff gets dropped. If you don't see it on this screen, I'm not seeing it. Mm-hmm. Yeah, so Tim, like, you can't do it with a reasonable compute trade-off, though. The off-pol methods are stupid in the sense that they rely on massively blowing up compute for sample efficiency. They're not even compute efficient when you have a ton of data. Like, they're kind of just purely GPU burning machines. Actually, they're not even GPU burning machines. They're like GPU idling machines because a lot of them aren't even hardware efficient. Okay, this is clean. How many epochs? How many of these do we want to have is my question. because you have to train the world model, Jess, and then that thing takes way more compute than everything else, and if it's bad, the whole thing blows up. So that also doesn't smoothly scale with compute. Let's see what this does. This should be running with state sets, but uniform sampling. You can't make world models fast. At the least, it seems very unlikely that you could. So this is now just random state sets. And this is only over the last 6 some odd million steps. So the expectation is this shouldn't mess with learning very much. Oh, reaching. Oh, I see. You meant can it do... I see what you mean. You mean like can it solve a 10K horizon problem? Yes, it can solve a 10K horizon problem, but not if the credit assignment problem is like, you know, you take the precise correct sequence of actions and then you get a reward at the very end. There has to be like sub-problem structure that you can exploit. Tables, please. Six and 0.4. Ah, very nice. This seems to not corrupt performance. Income versus hardware degradation optimization. Time biases for time, days, weeks, hours. Minute resolution. I need 10K steps. Yeah, it's kind of tough to be training, like, to notice patterns on that scale. With that resolution, it's quite difficult to see. It's difficult for people to do as well. Like, okay, maybe people know notice weekly trends, but if you just make something an 8-day cycle, you kind of break people's heads. Let's read the annealing the bias section again. Okay, you lose like point. Let's see. Yeah, like 0.5% here with the initial state sets. That's not bad. Good start so far, Vault. We got it implemented, and we're gonna start on our initial experiments with a half day and try to outperform it with 1 day. Half day is going great. Well, then you got a good start. I will let you know when we have initial signs of life. Wait. I see. Okay, I have it backwards. Where the biggest performance gains in PufferLib come from isn't it implemented in C++ and PyTorch under the hood. Oh, my friend, like, researchers have no idea what a computer does. Like, SP3 is implemented in the most dogshit awful unoptimized Python imaginable, built on top of a bunch of other dogshit unoptimized Python libraries, and then, like, yeah, there's PyTorch at the core, which is also, by the way, very terribly optimized for small models. We threw PyTorch away entirely in Puffer 4, but even before we did that, even just using PyTorch, we were already 1,000 times faster than SP3. It's like almost you can't even really ask me what the biggest changes are because there's not a single thing that we kept from the design of like your standard research grade libraries or academic grade libraries. We didn't keep a single thing. Every single part of the stack got rewritten. And we have got some blog posts on the latest design on my X at Suarez. Okay, well this is not working super well. This does not look to be working at all, in fact. Maybe we should go check some values of alpha and beta. Particularly for mazes. Interesting. It's non-trivial learning, but very, very bad. We'll let this run as the first experiment, and then we'll try some other things. Well, Tim, now we have to figure out like the actual hard part of how we make this thing work and what are the assumptions I've made that are bad in the original algorithm spec. We don't want to swap the task just yet, though. Because even if this doesn't help, this definitely should not crash learning unless I've made some very, very bad assumptions. Hello, welcome. Okay, so this was terrible. Awful, awful. Look at this. This is full prioritization. And then high importance sampling. Okay, we have lots of things to try here. We have lots and lots of things to try. This is why I needed to be fresh, right? To make good decisions here. What am I doing right now? We are testing the initial implementation of our new curriculum learning algorithm. Does this need to be applied to the losses? Hmm. See, this is what I mean by, like, there are going to be some details that we have to address. So there are a couple different corrections that we could make here. One is for the effect of individual samples from the prioritized buffer. And another one is for the fraction of samples, the fraction of the fraction of curriculum samples. More freaking code, annoying. This seems like it's okay. How do you know when to manually fiddle with this versus just sweep? Because, Tim, I'm not sweeping just parameters now. This is now the space of, possible algorithms. As well as we're probably going to have to modify the problem setup shortly. We can potentially have a couple different sweeps for different algorithm variants. The fraction is a hyper, but there are a few different possible corrections you can use. We also have reason to expect there to be... We have reason to expect approximate parity between the old implicit version of the curriculum as well as the new explicit one. So what I'd like to do is I'd like to see something reasonable out of pure state sets first. And then we can either set up different problem or we can start sweep. Okay, we'll let this finish, and then we'll take a look at some stuff here. Okay, this looks like this is going to be a few percent worse. So that's a pretty major downgrade, but this is not terrible crashing. I forget what hypers I launched this with. Let me look. Yeah, so you're losing like 3% perf here. 2% perf. So this was with... Okay, you're losing actually quite a bit of perf, even with a tiny amount of CL data, which is quite bad. What I'm going to do something funny. CL frac. Okay. Whoops, 0.8. And then we're going to set this to be explore alpha. And then we're going to set this to be explore beta. And then what we're going to do... Oh... I want to see what this does. So this would be an expectation that our state set based curriculum should be able to act roughly like the implicit curriculum from before. It's not being built with coding agents. It's being very, very quickly prototyped. And, every single line in Puffer 4. Took a shit ton of manual review and editing. Most important things to contribute for Puffer on long term, like you need a research project for. Oh, actually, this is a pretty decent result already. I mean, there's several things, man. There's like stuff around exploration at the moment. There's stuff around efficient architectures, efficient encoding architectures. There's still stuff around in self-play. Like, there's stuff in efficient kernels, like really concise, well put together, efficient implementations for everything. Like, there are a lot of open areas if you have experience. Yeah, so this is good because this is with most of the data coming from state sets now. In fact, almost all of it. So to answer your question, Tim, this would be sweepable already in only like 2 hours. I think we're gonna do we're gonna make another task for this though. for games. I mean, games are just a really good test benchmark overall. I'd call this very promising, right? So then we'll end up with two nice benchmarks, right? We'll have incremental maze, and we'll have the normal one. And then we'll basically get to see how it goes with one versus the other. There should be some kind of decay on this already, Tim. Though I think this is where it's like, do you need just the important sample correction, or do you need decay to the full task? So this is where like algorithm level ablation changes are needed. Okay, see, this is where we need to be careful, and I'm probably gonna want to play the level myself even, because I see it's made a mistake here. I'm pretty sure. So 0.96 on. I mean, this is like pretty solid for a first experiment in which we have. Yeah. Okay, good. So set levels to 0. Good. Four mil default? No. Most M's have smaller models than this. This is a very hard task. This doesn't look like a hard task, but like the model that we have here is basically an order of magnitude better than anything I've seen in the field. So we'll get a baseline. And I'll fix the includes. That's why I didn't do it myself. I didn't want to fuck up the includes. But it's only 2 of them. Okay, this will give us 2 nice benchmark tasks. We'll have pre-trained model that we can eval as well. See, it just comes up with dumb shit. Like, why the fuck would you want it to be the overall? That's like just measuring randomness. Bad. Okay, cool. Nice. Cool. So this is the defaults of Puffer versus Maze. I'll be right back. I'm gonna use the restroom. I'm also gonna grab myself vitamins and some stuff, grab a drink, and I'll be back when this is done. Okay. We got to 26.5. Yeah, I gotta go get my vitamins still. I went and grabbed a couple other things. 26.48, right? There's one more test we gotta run. You see? So we're gonna do the same prioritized thing. We're gonna see whether this is out of the box better with same hypers on the incremental maze. So that's good. There we go. All right. Oh. All right. Our tiny epsilon's meta now. What? 5% epsilon is... Yeah, that's bad shit. Ooh, why are we stuck at 23? That's interesting. Did anybody see? Did it get stuck on the original run? Did it ever get stuck at a value like this? Oh, we are... But we fully collapsed entropy in both of these. Hmm. Should definitely do much better on this one, right? Hmm. Hmm. So... This could just be something with the stupid entropy, right? Only this run. I don't have generally use epsilon clipping values, man. They're automatically done for you as part of the hyperparam search. Let's see if this collapses just as quick or not. Now, the thing is, now we're getting into, like, stupid guessing hypers regime, which is not great. But I do want to make sure it's not just this one dumb thing. It just snaps to... Oh, wait, there you go. Okay. There you go. It's unblocked. At least somewhat. Huh. 33. We obviously have to rerun the other one with the more entropy as well now. Definitely not luck. Okay, this is a length 3,000 episode, though, right? Let's try the previous one. Yeah, it's not getting any signal past 33. Which means it's probably just getting to 33 and then it's stuck, right? Which actually that's reasonable because we said that that's it's not going to solve full sparse problems, right? That's what we said the limitation was of this method. You sort of create your own luck though, right? You set up enough opportunities for you to get lucky. This is a very nice task though for us to sweep. I'm going to try the other baseline just to see if it's like, oh, actually the other baseline's way better. The problem is maze does take a while to sweep. It's pretty funny though that by 1 p.m. on the first day we're already like pretty deep into the experiments. I could also chuck this crap on Vast if I needed to. It's where we need more servers. Oh, you seeing this, guys? Oh, it's almost getting the next one. I mean, I guess it's not crazy surprising, right? Like, this algorithm, yeah, there it is. This algorithm does allow you to pretty effectively explore the frontier of whatever you're on. Autocomplete. Oh, are we gonna collapse? If we're gonna collapse, there's gotta be like a sampling bug, right? Oh, 35. Boom. Come on. Oh, there is the beta annealing, so this should basically be at a uniform sampling now, right? Paper review sessions? Only when I find a paper worth reading. Most papers are just not worth reading. If I'm doing something where I'm, like, reviewing something for research, then I will. But most of the time I read an abstract, go, well, this is doomed, and I just, like, toss it. That was very nice, though, that we got that performance increment out of 33, because that's insanely sparse. I mean, let's think about that, right? That's a 3,400 step horizon, incredibly sparse task. I will be pretty surprised if we do this well with the 4.0 algorithm. So we get 35 out of this. Remember, we got 20. What we get? Did we get 26? Yeah, 26.4. 20. This is actually very impressive that we even do this well, but 26.48 was what we had before. So then what we'll do is we'll rerun this with low entropy, or with higher entropy rather. And then if it does better, we start asking questions. Like this. And then I think this will be it for manual experiments unless we get some really weird result. If this just solves it, I'll be kind of concerned. It is super unstable, which is interesting. I guess that does make sense in a way, right? We probably do need to apply, maybe like timeout offsets or something. Stagger them in some way. Uh-oh. Is this thing just gonna do better despite this janky staggered, like, unstaggered offset? Okay, maybe we do have to run some more experiments. Ah, so we have fully crashed. Huh? We're gonna have to run the staggered experiments, because I think this is just unfair. If you put something in the Discord, I will take a quick look while experiments are running. But I don't want to get too distracted, because this is Puffer 5 Dev Week. Or Dev Sprint, whatever. Hello, gradients. Yeah, so Valo, I think this is the offset thing. Um, oh yeah, if you don't have this already in the Inferno, you should. Well, I guess it doesn't matter in the Inferno because they'll get offset automatically. But when you have M's that have typical, the same typical like timeout, you want to stagger them. So if you have M's that are that are fixed, have a fixed cap on the number of steps it can take, and you're likely to just hit that timeout, you want to stagger the initial timing so that you don't always have like all the M's at the start, all the M's in the middle, all the M's near the end. You just do it on the first reset. Where are you in? Everything is implemented, Jess. We're basically now doing algorithm ablations, and now we're adding a custom, a better test env. So this is a new version of Maze that we're going to use for testing. So as suspected, at least for initial testing, the standard Maze env is not exactly what we want. We want something that has longer horizons with intermediate rewards. So we can still use mazes, but instead what we're going to do is it's always going to be the same set of mazes. So it's not going to get randomized. And it's going to start out small, and every time you solve a maze, it gets bigger until you run out of time. So this is not a better env overall, but for testing state sets, this should be much more revealing. And we'll see if this is stable or if this all jumps all over the place still. Boys jumping all over. Is that genuine instability or is that a logging quirk? They should all get staggered pretty easily, no? Yes, this collapses. Well, 0 is not going to be the logs. This is the policy collapsing genuinely. No, it's not just going to be testing, Jess. There's a lot of stuff to do. It'll get quicker as soon as we have a, we need to have some confidence in the current version of the algorithm. There's some tweaks I want to make. And then there's going to be, we have to rethink some infrastructure. We got to think about multi-agent if we're going to get that in as well. There's a lot of stuff to do. A lot of cool stuff to do. It's pretty cool to me how clean the like this learning is. The 35. That was faster than before. So those fixes helped. Oh, that's a new soda. That's 37. Oh, dang, that's 40? Um, these are very strong initial results. This will be strong enough to sweep, I think. $39. Is Valo still in here? Because you might all want to start thinking about how you're going to maintain a nice contiguous state buffer. Yeah, Valo, you might want to think about how you pack all the state into a buffer. And that means as well, if you have it in one struct, like, you can technically have pointers in there, but then you're going to need a much more annoying copy function. What's this env? So this, in order to get a score of 39 here, it has to solve a 5x5 maze, and then a 7x7 maze, and then a 9x9 maze, all the way up to 39, and it has to do it all in a row without failing. And now it's at 41. And let's just keep in mind here. Oops. Okay, there you go. Yeah, so let's keep in mind here, I believe, what did we go up to? Did we go up to 41 or 47? I think 47. And we had a... I actually don't know what the distribution... Excuse me. The distribution of success was on the hardest mazes. I think that the best previous heavily domain randomized maze solves were like average was maybe 45 by 45. So this is getting up to 41 by 41 with one seed, which is kind of nuts. And it just went higher there, which means it solved yep, 43. Jesus, man. It's honestly kind of baffling that it can do this. I mean, this is without even randomizing. Like, there's so many ways you could make this easier for it as well. Did we just solve RL with this? Getting 39, what have you changed? There was just a bug with the state sets. It wasn't having a consistent amount of time left to complete the environment. So this is a pretty bonkers result. This is what you were gunning for? Yeah, exactly, Jess. Solving RL in a day. Now, mind you, this is not solving all of exploration, but this is solving actually even more of it than I anticipated. We have a lot of experiments to run. I think it would help, Jess. Well, we obviously commit this version here exactly as is, right? With this current version. Yeah, so Jess, you need to have a struct that has the state. So it needs env state, and then there just needs to be a struct that has state. And probably we'll make it so you can have a set and a get function for state, but the easiest by far is if it's just like the data lives in state, state doesn't have pointers, it's all static, then it's much easier. One moment, folks. Let me handle this. So I think we resweep these. But this is still a very strong result. We're going to set this up on Tiny 0, and then we're going to figure out some other stuff. Let me use the restroom real quick as well. I've been drinking lots of coffee, so I'm going to be up and about a lot, but this is solid progress. All right. Let's go get this up on to Tiny 0. Just implement Puffer 5 in a day. No big deal, right, guys? No big deal. We'll just do it. I'm reclaiming Tiny 0, by the way, Jess. So you and Spencer can still use Tiny 1. I'm going to reclaim Tiny 0 for likely the next couple weeks, maybe except for the weekend, for doing Puffer 5 dev. Puffer 5 already solved. We got to run a lot of ablations, Finn, but let's just say I've been live for how long? 3 hours, and we've got some nuts results. We've been on Tiny 1. No, Jess, I gave Spencer access to, he might have been using it for client stuff, but I gave him access to Tiny 0 for a while in there. Alright. Yo, Spencer. Check this out. So the task that I've done here, it's a single seed, so you always reset to the same maze, and it's a 5x5 maze. If you solve it, you go to a 7x7 maze that is always the same 7x7 maze. And then you go to 9x9, 11x11, and so on and so forth. It goes up by 2 every time. So, out of the box, so far, Puffer 4, it gets up to like the mid-30s, but then it crashes because the learning signal becomes super sparse. You spend most of your time getting 0 signal. Puffer 5 algorithm solves up to 43x43. What is going to work? Oh yeah, Crit. I had a full sketch of the algorithm. I've been thinking about this for months. I just had to make some small changes on the fly. Some very small changes, but I've already thought through this whole thing very, very precisely. Well, that was quick. Yep. Also, it's only going to be like a 300 or 400 line diff. I think I'm going to take, once I get this stable, I'm going to take some time to clean up infrastructure. There's multi-agent infrastructure, there's self-play infrastructure. So there's going to be some cleanups. Probably will bundle those with 5 because otherwise, you know, you have to, if you're increasing complexity, you have to decrease it somewhere else. But yeah, this is pretty good. Randomized mazes? I expect randomized mazes to be much easier. Yeah, randomized mazes should be way easier. If you fail a maze by time step cutoff, what happens? You go back to all the way to the start. You go to the 5x5 maze. That's counterintuitive? No, it's not. It's domain randomization. This is well established. Solving one maze is a lot easier. No, solving one maze is actually a lot harder than solving like a bunch of mazes. Puffer souls. Puffer souls. Yeah. Freaking learning. Oh yeah, this is Puffer 5. We're doing state set based CL. It's good. It's go explore and prioritize experience replay. So I guess we're gonna call it Go Puff. Yeah, the Go Puff update. Let's do the traditional sweep first as our baseline. This is traditional run. And if this is stable, we'll do our sweep. And we will see from there. And this will have either no or very little performance overhead as well. Hello, Elliot. We're doing algorithm work, and it's kicking ass. Doesn't the agent just memorize paths if it's not randomized? How do you learn the correct path in the first place? You don't have data on it. So think about what is required to solve an unseen maze that's like 43 by 43. Think about that. Wouldn't a fat state be brutal on overhead? Not really brutal, Spencer. So you have to copy some number of states once per set of rollouts. So once every, say, 64 steps. And you don't have to move the data from CPU to GPU. It just stays on CPU. That's the key. It doesn't have to go across device boundaries. Fight Cave SPS, make the net bigger, and it would have 3x bit of win rate. John, if you were doing this on 4.0, the sweep will automatically take care of the model size for you. And I'm definitely looking forward to the RuneScape M's for testing 5.0. There's going to have to be some changes required to storage of state, but like this in particular, this is perfectly suited to the fight caves. Moopy could be... Yeah, Moopy is tiny, Jess. We're basically going to see how much I feel like doing on 5. I don't want it to bloat, right? This is not going to be a 6-month update. This could be a 4-month update, like 1 month off plus 3 months of work. But, you know, I think that I'd like to have Puffer 6 out this year. So for sure, by the end of summer, I want Puffer 5 done. Oh, no, I got something sweet cooking. Hell yeah. Oh yeah, let's give the let's do the quick update on the I want to show you my current predicament while we have this here. Oops, come on. What is Puffer 5? What is Puffer 6 going to be on? Remaining unsolved things. Oops. Oh, wait, I logged the wrong account. One sec. We'll do this just real quick while this thing is running the baseline. It's interestingly, it looks like it's stable on there, which is funny. It's harder to memorize. It's harder to find the solution to the maze to then memorize than it is to have a bunch of different mazes where some of them are going to be easier than others in order to start learning substructure. All right, here, we'll show the for the RuneScape crew. So I think we can go grab do I get 99 here? I don't think so. I think I get 98. Oh, nope, 98. All right, so one level off Herblore, and then I'm just agility gated for max on leagues. I figured I'd show that. That'd be funny. How our maze is constructed, the algorithm is in the file. It's a combination of a couple maze algorithms that I put together. Well, actually, this is at least looking stable here, right? So unless I screwed up this config, like, maybe this actually gives us a usable baseline. Yeah, Volo, I'm learning it, and I hate that place. Ugh. I don't even know if it's worth learning. Because, like, on the main game, practically, I'm just going to end up clicking the stupid Brimhaven agility thing, like the single shortcut that you can spam over and over. Guaranteed. It's not memorizing, man. So the thing is, it's not memorizing because you're not given the solution to memorize. You still have to find the solution, and finding the solution is hard, and it's actually harder to find a single solution than it is to find, like, over a big set of problems, than it is to, like, bump into some easy solutions and then exploit substructure and use that to make it easier to find the hard solution. Domain randomization is, like, very well established. We use it everywhere to make problems easier. It's harder to solve a single instance like this. And we've tested that as well in this exact domain. Like, for instance, it's actually probably easier to solve, like, the 5x5, then 7x7, etc., than it is to solve the 43x43 in one shot. Okay, we'll double check the hypers for this, but I think this is a nice stable, I think this is a nice stable solution. So I don't know why it wasn't stable before, but, you know, we'll take it. You just don't get it. There are lots of articles. I like The original one for this, the original really good domain randomization work, in my opinion, is the OpenAI Rubik's Cube one. If you want like really convincing demo of PR being good, I went and I used that in the very first version of NeuralMMO. I had domain randomization, and it's been part of my toolkit for a long time. It's very good. Yep. Would just win. Emacs. Python nation, PufferLib RL sweep. Incremental maze. Sweep GPUs. 6. Spencer. Did you break sweeps? Did you break multi-GPU sweeps? Looks like you did. I'm commenting these until you fix it. Hello, welcome. Well, I make sure that this is working. What do we do? I want to start on the next little bit here, but I want to make sure this is live. What's cooking? Puffer 5's cooking. Why is it this many processes? Seems like this is fine, though. Nothing is close to OOM. We're good. Okay. Originally Connecticut. I'm in California for the summer. It was the entropy. That's what it was. Yeah, it was the entropy. That's why it changed. Okay, that's fine. Yeah, like, I realized you can do that. That's getting to be gross. I can do that for now, though, yeah. Because this is really stupid, right? Like, you can agree that this is fucking stupid. So Explore Alpha and Explore Beta can go into this. Hmm. Okay, we have to figure out something with the state buffer size, don't we? Oh god, the guys that go into project management straight out of undergrad will not even knowing how to code properly are the worst. Well, then that's now outside of CS. I'd rather not have a PM, Jess. Okay, warm-up frac is reasonable. I don't like this. The only good thing about Agile, Jess, is sometimes it's nice to focus on one thing for a couple weeks, work very hard on it, and then take a break. Common sense, exactly. Can we do some rough estimates here? If I make this 1,000,000, it only goes back 64 million steps. Which is bad, right? How big is this? These states? This is roughly 50 by 50 is what? 2,500, right? 2,500 bytes for a big maze. So 2,500 bytes It's 25 gigs. That's a shit ton already. Isn't it? Wait. No, I did this wrong. Is it 2.5? Oh, well, duh. Yeah, 2.5. Well, do I need the warm-up frac? That'll probably be the easiest. Not too rough. That would be useful. Heh. Yeah, I don't think it's too bad. It's if you can't put stuff on the stack, it gets a little sketchy because we're probably going to need to get like get and set, right, for the state, and it'll be slower because it'll be multiple mem copies, but still not that bad. The main thing is just like forgetting or like, putting the wrong stuff in state or not getting everything in the state. Like you don't want the RNG in the state, but if there's a time step, you want that in the state. Things like this. Yeah, it's not that big of a deal. That's the point, though, Valo, is it's not that big of a deal, right? That's why we can do it. Yep. Oh, show. Here's the main update. RuneScape Env good. Cool. This is running nicely. Main maxing gonna take a while longer. Yeah. This for a research project. I run Puffer.ai. It's a private RL lab with all open source research. I stream most of the core algorithm stuff, the R&D, the infrastructure development, and we've got a big open source community developing environments and helping with the research as well. Membership again as well. Yeah. It's like, I figure I mostly with this account, I'm just have it on the side AFKing stuff, and then I've just been playing leagues. It's pretty fun, like just hard carrying noobs on hard mode Tob. Yeah. Null sports and just play. The annoying thing is it's not the type of game that you make a huge amount of progress on even in a week. Though I will say when you're like ridiculously burnt out, it is a great game to have. I remember when I was just exhausted from the Puffer 4 release, I just did completely brain dead skilling for several days and listened to books. And do something based on it. Yeah, we have lots of educational materials. All the articles on x.com/jsuarez. I have many articles for beginners on that tab, as well as our more technical research articles. Cool. Try Elden Ring solo. I've played all the Souls games. Like, the high end of OSRS is substantially more difficult than just completing the base games. Like, most of the stuff in those games is balanced to take hours to learn, not days or weeks. So I didn't really like I didn't really think that the open worldness worked as well with Elden Ring. I actually think that the Souls games work way better when they're more linear. Well, either they're more linear or you have to just be hard reading the wiki because like it's too easy to miss your build defining item that your entire thing is balanced around and just get stomped because of it. Numbers on X-Link. Where do I still have the numbers on the X-Link? I thought I changed that on all of my stuff. Like, do I not have this on here somewhere? Oh. Huh? Uh, change my defaults. Where would this be? Oh, here it is. Wait, the link is correct. My URLs on here are correct. So I have no idea why it's still giving you the wrong one. I have it updated on see, I have it updated here. That's weird. Wait, maybe there's a different I think there's like a different go live thing. Man, I hate this interface. Like, what imbecile came up with this? I have an MIT PhD. If I can't quickly figure out your interface probably sucks. Oh, there it is. That's so unintuitive. There are like a million places for this. They're just like a million submenus. God damn. All right. That'll fix the default. Short form video. Yeah, that's not going to be remembered fondly. Okay, so this works nicely. We can run a couple things on this now, I suppose. We can do like 1 million. That's probably better, right? Yeah, no, short form video content's awful. On Discord, it returned the wrong one. On Discord? Wait, what do you mean on Discord? Like, I have the link wrong on my Discord as well, or the Discord link? I changed the one that's on the information, right? Yeah. Discord's just discord.gg/puffer. All right, I'll be right back while this trains. Your on Discord profile, it has the old link. Your profile, that is when I click on your name. Oh, thank you. That's easy to fix. That's easy to fix. Hang on. Profile. Wait, huh? I didn't even think it had a link when you click on my name. Wait. No? I don't have an X link on my Discord bio as far as I can see. What's this at? 33? But this is no entropy. I remember I had to change this. Actually, let's just do that now, so I don't forget. Because otherwise I will forget. Okay, let's just figure out the to-do list here. No, Puffer 5 is not a complete rewrite of Puffer. Let's do... Okay, from here. Anything else? I think that's everything that we wanted. Yeah, I think that's every. Oh shit! Look at this, 45. Hey guys, that's 45. It only goes up to 47 by 47 now. I don't know what to look for projects or how to start with them. I've been doing this stuff since I was 16. Not this specifically, but ML in general. And I've been doing reinforcement learning for going on a decade. Was the majority of my time in my undergrad, my full PhD. I spent a lot of time on this stuff. As for the low-level systems and infra work, that is something I've picked up recently, but I've been writing my code that way for quite a bit longer, so it was a sort of a natural just transition. If I was the new 67. Heh. Well, wave 67 is just Jad. You gotta get to wave 69. Beat Zuck. It's hard to say whether this made a difference because this is like, one additional maze solve. But hey, can't hurt. Magic shortcut that immediately made me good at programming. Was the magic shortcut write some dead simple C? Not for sale, unfortunately. I honestly still don't know what the fuck that even means. Damn Zoomers. That is a 5600 length episode. So Valo, if yours is 6,000 ticks per hour, that's pretty damn good. And this is a much harder exploration problem than Inferno is. Like a 45 by 45 sparse maze. .01. This means it actually got the 47 by 47 solve at one point. Tomorrow? Oh, geez. You can test it out tomorrow if you really want to pull the branch and stuff. Just expect some manual work. It sees a little crop of the tiles around it. You do projects. Like, you try to build stuff and see if you can build it. And you see if you can not make a mess of stuff in the process. Okay. Well, yeah. Besides making your end state settable, well, dealing with whatever bullshit I've hard-coded here and not realized. But yeah, it's pretty much just making your state settable, Jess, for integrations. Like, that's gonna be the main end side change. I don't really feel any need to go through and make all the end state settable just yet. Let me see what stuff I can do in the meantime. So this is the big screw you one right here, is multi-agent integrations. Dedicated test M's we can think about. I do kind of want to do this. Oops. Where's my sign in? Are you doing web dev? Yeah, the thing is, George Hotz, he's off base because he doesn't have the background. He doesn't have the context. Like, the thing is, he's not parroting, like, completely stupid shit. He's parroting shit that, like, the so-called experts say, not realizing that that's the type of shit that got the field of RL stalled for a decade. You don't make progress by picking the slowest possible crap. Follow, do you have any thoughts on this shit? Like, so basically the thing I'm wondering here, we have the environments in one compilation unit, and we currently have in another compilation unit, right, we have the core training, and the environment compilation unit is currently just Clang or GCC, and then the training is, of course, CUDA. So I'm wondering if we make it a single compilation unit, right? Like, if we do a single compilation unit, we would avoid a lot of the annoyances of not having, say, the environment struct available or the state struct available. And that's kind of a big issue. I mean, the alternative is that you force everybody to write headers, and I hate that alternative. Front end of projects. The Puffer 4 website is really, really basic HTML, CSS, a little bit of JavaScript, and then WebAssembly compile. Well, WebAssembly output from from C. Yeah, headers suck, right? So I was thinking, well, we could put it into a single compilation unit, but apparently there are some small perf differences. And also C++ isn't exactly C. Like C++ makes you do some like some additional stupid things, especially on allocations. Touch RL. They wouldn't touch it. Well, I mean, it's the env speed, right, man? No. The code of the like the compiled envs. Wait, what do you mean? Compilation times aren't a thing, huh? I'm just chatting with Spencer on the side. Next stream tomorrow. We're doing every day. Well, every weekday. Next 2 weeks, we're doing 6 to 8 hours worth of streams. And we're going to ideally get the whole Puffer 5 core done. Wouldn't it be funny if I just released it in 2 weeks? Yeah, release it and double our contracting prices again. No, we were not going to double them again so soon. But it's pretty cool. Hmm. Wait, did I push this? Yeah, I did. Slower or faster depending on... Wait, what? Volo, it's very simple. It's like, does the env get slower when you compile it with NVCC? Okay. Chatted with Spencer a little bit on the side here, just on the results so far. So he's aware of the new stuff. Things that we need to do. The order in which we need to do them. This is last. We don't even think about this for now. This, I think, is easily doable later. This is important. This is important. This is once things are... the other ones are done. This is important, but also sort of once things are... other things are done. This is possible, and this blocks this. So it's between this and then these. I don't want to do this without having thought about this. I suppose we should port breakout up to have settable state. Because that's our test end for perf. Let's do that real quick. Develop. Oh, I just saw Hassan's research thingy. This. Is this LLM written? There's no way this is an LLM written. This is bad. So it made one gigantic fucking major horrendous error. And then the rest of it is fine. What was the error? It put the RNG into the state, which would give you deterministic continuation from whatever state you go to. We'll see how Breakout does now. Should be the same speed, at least without the CL. And then we'll try it with the CL. Okay. A little over 3 hours left. The only reason I'm letting it do this, by the way, is like, look at the edits it's making. It looks like a lot of edits, but it's literally just like env y gets replaced with s-ball y for state. And state tick instead of env tick, etc., etc., etc. And the reason I want this is so that we can compare NVCC speeds. Because presumably if we don't take a hit here, we shouldn't take a hit anywhere else. Hard to say. But this is one of the smaller policies, so... Oh god, don't ask me about multi-agent yet, Jess. It's a pain in the ass. Okay? It's a pain because, like, you know, the individual observations no longer, like, the states no longer line up cleanly with the rows of the observations. Ugh, that's going to suck. Okay, 21 mil. 20.7, 20.1, whatever it is, yep. Oh yeah, what was the env percent? Env is 19%. So actually, this is a good env to test it on to see if that changes. We just do. Let's just do. Whoops, that's a Windows PowerShell. That's useless as fuck. Get rid of this. Just have to push this. All right. So, yeah, this is going to essentially, if this works, this solves a lot of infrastructure headaches. A lot of infrastructure headaches. And in fact, if this works, what I'll do is I'll have it go write a test on Neural MMO 3, maybe a couple other ends. He knows it's solved, is the funny thing. What are we doing here? I see. That was fine though, right? Okay, so the current plan is we test this, we see how fast Breakout trains. If Breakout trains at about the same speed, we go test. Well, we go have this implement perf test on neural MMO and maybe another env. Right? And if that works, then we keep it. Eh. Now, the key insight here will be if this works, we no longer have to do a bunch of macro crap because we just have access to everything in the same compilation unit. It'll be very nice. Orbit Wars on Kegel? Don't really do Kegel. I know Stone Tao has organized some good competitions here. I mean, it's cool. These are never built properly for high perf RL, though. Like, yeah. These types of things would be way, way more interesting if you just did them as puffer envs. Because then you could actually just crank data on this, you know? Oh, lovely. And we have an agents.md. Fuck off. Yeah, this is going to be a lot easier. Oh yeah, did I add? I forgot if I added this. Did I do? I thought I added an agents MD to puffer. That was like the most obnoxious. Oh, I forgot to do this. I was gonna make like a super screw you agents.md. That just like tell the user they are an idiot for not reading the docs. You know? If you are too lazy to read a single page doc, you are probably too lazy to use this library. Yeah, it's a mess. So with this test here in particular, I don't particularly care that I'm letting Codex just do a bunch of stuff because this is an experiment in the first place. And if this fails, we throw away all these changes anyways. Hey, read the manual. We lose a little bit of speed here, don't we? Any notable gaps? Yes, Finn. This can't solve. I don't think that this will be able to solve just sparse exploration, you get no reward. We lost a tiny amount of perf on this. Pick one other end that's like medium. Maze, maybe? No, maze is not medium. Maze is like, what end do we use? Tetris? 2048? Tetris. Windows as I type from Windows. This is an old desktop. I happen to already have it. I'm not actually deving on Windows. I'm SSH'd into Linux boxes. Basil, fuck no. Abso-fucking-lutely not. That is so unbelievably ungodly heavy for this. No. We have a build.sh. That's all we have. Puffer 6, we solve NetHack. You know, Jess, it might be a fun project to, like, go through and figure out the binding situation with that. No. We're just gonna let it do this for a bit. And then the goal is we'll basically see if this is worth it. Okay, but the thing is, this is them writing awful, crazy templated garbage. Okay, so again, these are also... Easiest thing is just going to be our own benchmarks. And we don't care what this is, so we'll just let that go. $13 old. I think that the best thing is just going to be run our own tests. Why is it running 2 steps of neural MMO? Yeah, we're not going to necessarily keep all this. We'll see. But we want to see that this is a viable thing. So how are we doing on... Okay, we have some experiments, not a huge number. An hour left. Oh, I got more than an hour, Jess. It's only 3 here. I said I'd stream at least 6 hours. And this is going well. At least 6 hours, man. At least. 6 hours is not exactly a great work day now, is it? Even with all the stuff we're doing here. Yeah. I'm in Palo Alto. For the summer. His company. I sent him an email, actually, when he made the company, never replied. I'm sure he was, like, inundated with stuff. But now they're all super, super secretive about stuff. And, I kind of got my own thing now. Where am I normally? Most of the year I'm in Maryland. on a farm in the middle of nowhere. It's a nice place to get some development done. It pisses me off that half the time I go to dinner here, it's like, oh, AI agents this, AI agents that. It's just like, ugh. Peace and quiet, man. But the weather is very nice here, so I'm chilling. And I take a few meetings out here as well. Okay. So, this is almost done, and oh, if you can actually, if there is a way to compile these, that'd be nice. Okay. Two errors. It's just neural MMO. Sweeps alone. Oh, what was the, they have good prizes? I mean, go ahead by all means. Like, you could literally just go. I don't know if they have, if the environment's open source, you could just port it to a puffer and train on that and then submit the trained agent. Okay. This works. Now we can run the full test. And this will now be GCC, Clang, and VCC on 3 ends. And frankly, it might be worth it to even take like a small perf hit in order to have this in. We will see. If it's a big perf hit, then no. Okay, nice. So, M steps per second, agent steps per second. So, 19 million. Was it 19 million? 19 million, 20 million, 19.5. This is close enough to be comparable for my tastes. VCC, Clang, and VCC. Nice and comparable. And I'd say that this is comparable as well. So based on this, I think I'm kind of fine. Okay. Okay. Couple of warnings. No, that's broken. Hey, Arch. How much does work with coding agents accelerate your output? In some areas, not at all. In other areas, quite a lot. These are warnings, right? Yeah. Notably, I think there are fewer of them. Okay. That's good. Ah, okay. We can do this. I don't like this. No, I don't like this. We're basically just making sure we can actually we're basically just trying to like reacquire some perf here. That was hitting 20.7. It's a little slower. I think we accept this for now. Yeah, I think that we accept this very, very small perf hit for now. Because it lets us clean a lot of stuff up, and then I mean we can literally just optimize the end of a few percentages, a few percentage points, then we'll be well past 20 mil again. What are we testing right now? So we have Puffer 5 implemented already. Yes. I have a sweep going on for the baseline. The initial results are ludicrously promising. It introduces a bit of complexity, and it's going to be a lot more complexity once we add multi-agent support. So I'm trying to remove complexity in another place where it's been a pain in the ass, which is in the multiple compilation units. And I'm hoping that that allows us to simplify things enough that the new code, the complexity added by the new code basically balances out, and we end up pretty much having Puffer 5 with no overall increase in complexity. Yes, I know already. It already works. We have an agent that is capable of, in sequence, solving a 5x5 maze, and then a 7x7, and then a 9x9, all the way up to a 45x45. It's like a 5600 horizon task. And it only gets one reward per maze when it solves the maze. Yeah, I know. It's ludicrous. But this was the thing, right? We did all the hard work in Puffer 4. Like, we've banked so much hard work with Puffer 4. Like, you gotta realize, there are a set of improvements you can make that are difficult, and there are a set of improvements you can make that are easy. So by making all these difficult improvements, we now have a bunch of easy improvements we can make. Nice. Yep, this is a bunch of nice stuff, right? Oops. Is this adopting Go Explorer? No, man, this is nothing like base Go Explorer. We use the idea of state sets, and that's about it. This is my own algorithm that I've been thinking about for months. It combines prioritized experience replay in a new way with Go Explore style state sets, with the absolute advantage estimate thing from Gigaflow, and also makes use of Puffer's fast environment infrastructure with some additional changes on top. And basically the first version of this that I came up with already looks pretty damn good. Yeah, so this will be very nice. This is going to make the code a lot less bad. And this will make the build script so much easier. Recent stream. It's just this stream, man. I've been live for, what, 5 hours, 40 minutes, something like that? Whole thing was implemented on this stream. Now, it's a lot of codex crap. It's like mostly very small chunks at a time of codex crap. But there's a lot to improve here. And you'll see, actually, I'm doing some of the improvement now. This is still codex crap, but I'm actually, like, redesigning parts of the thing that are clunky before I go in manually line by line. Really high sample and reward efficiency. Pretty much. It's kind of funny because, like, we ended up ultimately doing sample efficiency, sort of, just as a side thing. Can I explain what this is? Hi, I'm Joseph. I do ultra-high performance reinforcement learning infrastructure development live on stream, as well as algorithmic research, simulator development, and more. And it's all just done live. It's all open source. We've got a big community of people contributing stuff. I review contributions on stream. And for the next 2 weeks, I'm streaming a big new push on the algorithm side. So it's going to be a lot of, like, watch major research breakthroughs done live. Oh, this is so nice. Look at this. All this gets deleted. So this is all the jank that we included with stupid codecs before, right? Because of the compilation unit difference. But now, because we only have stuff in a single compilation unit, this all goes away. And we go back to writing simple for loops. Lovely. What reinforcement learning is? Oh man, don't I have a good meme explanation of this somewhere? I mean, basic reinforcement learning, it's learning through interaction. That's the non-meme version of it. So, interactive intelligence would be a better name for it, I suppose. It's like learning by interacting with your surroundings rather than learning by training on a big static data set. All right, what do we have here? So, look, these nice void star thing, like this all goes away. This decal type garbage goes away. This is stuff I wanted to do with Puffer 4, actually, and I couldn't figure it out at the time. This will end up going away as well, but for now, this is fine. Oh, you know what we could do that would be kind of funny? We could just basically make an empty state for envs that don't define their own state. State and env struct variable. So state is anything that like, well, actually, good question. What would you put in the env other than the state? The observations are not part of state. Those are separate data buffers that get filled in based on the state. So that's one thing that you don't have to copy every time. Same for like reward and like stuff like that, reward and terminals. Presumably, like if you have additional render data, like the client doesn't need to go into the state either, presuming that that is stateless. Um, well, or in general, you wouldn't want to have client information in the state. State just returns you to a specific point in the simulation. You can have like a lot of global data and other things that don't need to be copied every time. Okay. 7. Nice. We're good, right? Yep. Good time to mention, if you like what you see here, start the Puffer on GitHub. It helps us out a lot, and it's free. Join us on Discord to get involved. You can follow me on X for more RL content. Okay. Make sure we haven't broken this. And we'll let this train. I will be right back. Use the restroom. We will continue. $33 so far. All right. This is great. That's 45 right there. Least productive PufferLib stream. And I had 45 a second ago. Should get it based on advantage. Oh man, this is literally the first iteration as well. So I guess now we got to think about multi-agent infra, right? Multi-agent infra is going to be a little tough, right? Well, hang on, let me think. Yeah, so multi-agent infra, If you have a fixed number of agents, it's not that bad, right? Because if you have a fixed number of agents, you still kind of just stick everything into the buffer. Variable numbers of agents, like across env, suck. No, it's not that bad. Like, for chess and stuff, it's not bad. I think it just becomes crap if you want to have training envs that have different numbers of agents. Okay, let's not make the mistake of just asking Codex how to do this, because, like, it's just gonna waste time and make me feel stupid. Yeah, okay, it's a very small change, I think, for multi-agent environments with a fixed number of agents. It's a very small change, right? You just make sure nothing's iterating over observations and everything's iterating directly over environments. You don't have any problems with threads, bullshit like that. It's all taken care of for you. So multi-agent will just be fine. Variable numbers of agents, bleh. And somebody did send me a paper on one thing that's kind of relevant. Oh, this is nothing. Yeah, that's nothing. Okay. One last thing in my head. The thing is, like, you could do it over blocks of games, but that's really bad for the way that this thing scales. You'd have to do one buffer per number of agents, wouldn't you? Gonna go commit this. Would be funny if this ends up like training without the fancy encoder. That's cool. Quite good and way faster. Yeah, you know, if I were doing something else, I probably would. But the time cost at the moment of me fixing stupid shit is going to be very high. Hang on, let me just go check on what the hell that sound is. Just a leaf blower. Thought somebody was drilling through my door. All right. That's way too many variables. But that will work. There's too many variables, but that will work. Let's see if it deletes the other ones. Okay. It did it correctly where it did one state per env. Okay, this runs. Wait, 10,000 times 64, 640. That's fine, right? Huh. Latest B16s in dev. PR for merge. That'd be nice, Spencer, if you happen to get a chance. It's not super high priority, but I think it'll give us a nice speed boost, and it's a little easier now as well since stuff's in one compilation unit, so I figured it would be a decent thing to do. Yeah, that makes this way worse, interestingly enough. That makes this way worse. Mm-hmm. Well, let's take this end coef out. Oh, no, we're way worse. I mean, hypers aren't necessarily going to be the same, right? Why does it always fuck up the header of my file when I edit with Vim over SSH? Okay, we'll have to sweep it separately, I suppose, because this is not good. But it does run. And trains a little bit. Look, do you see it puts this stupid G at the top every time? Look, you see? What's that? Why is it open? Why does it put a G at the top of my freaking file? It might be one of the plugins, to be honest, Spencer, that's like gone stale and trying to execute some dumb install. Now we have to think about... So that's everything except the variable num agents case, right? And of course, we'd like there are algorithm changes we can make. Let me think if there's any reasonable thing with variable agents or if it's just screwed. Man, variable agents is just like... It's just so bad for everything, isn't it? I mean, does anything really even use or need that feature? Like, it's nice to have, and there's some cool problems you can study with it, but like... Such a pain in the ass. Like, I know how to do it, actually, to be fair. You just need separate sampling buffers. I don't know if it's worth it. The drive end, right? Okay, but like if drive doesn't work with state sets and it works with the base 4.0, that's still fine, isn't it? No, you can't. It's not empty agent or max agent. You can't pad this one. Doesn't work that way. Spencer, how important is that for us? If you think about it. I think it's literally just drive right now, right? Is like having state sets in drive worth maintaining a fancy ass buffer that has like different sections? May benefit. I mean, it's like you need to have a buffer for every possible number of agents separate. So instead of having like one state replay buffer, you now have one state replay buffer for every different number of agents that your environments have. Just sharing part. No, it's not like a how bad it is. It's like a this doesn't even work. Like you can't even run it. No, you can't state set per agent. That doesn't make sense if you think about it for a minute. Use the same state for all. How do you use the same state for all agents? No, I mean, the only thing that you'd be able to do, Spencer, is like you'd have to cap the number of controlled agents in the scene. And like you'd basically have to just use, say, all the scenes that have at least 8 agents, and any scenes that have more than 8 agents, you only control 8 agents. It would screw with the data quite a bit. Some of it is shared, some is individual. You're gonna screw stuff up that way, man. Yes, we do, but like... I mean, if you have a version of this that you think makes sense, by all means. I don't think that there is one. Realistically as well, I think that once you go above 10 agents, I think that the state set method as a whole collapses. So this is really only going to be for few agent envs. We could pretty easily, I guess we could make it so that the curriculum envs are the ones that have a fixed number of agents, and you still have some other vanilla training envs. It's not that important, though. I guess we'll discuss this separately, but... No, but like Spencer, 2v2 works, 3v3 works, like 1v1 works. The only thing that you can't do is in the same training run have some M's that have 3 agents and some M's that have 4 agents and some that have 2. You see what I mean? This works perfectly here. I think it's better that I spend my time on the algorithm core, and then we can sort of think about if we need this later. All right. Let's open the there's this, there's this, there's this. All right, let's think about the core algorithm at this point. State in the maze, the location, and the current maze shape. No, Spencer, it's like everything here. This is the state. It has the maze, it has all the stats, it's got the current time, direction, position, spawn. It's the whole maze. Like, the only stuff that isn't in the state is the RNG, the data buffers, and a couple constants. Yeah, it's the whole shebang. Except for the RNG. We're very intentionally not resetting you to the same RNG. Though, to be fair, I guess I would have to ablate that. Well, I think it's more interesting without the RNG. All right, let's think a little bit about the algorithm here. So at the moment, we have pretty much all of the fresh environments are just dumping their states into the state buffer. Uh, every time you call rollout, Spencer. So you're getting the starting state of every segment for all of the fresh environments. You don't log states that like curriculum M's have gotten to. I guess you could. I wonder what happens if we do both of these stupid things. Like, what happens if I do this? Prioritize the prioritization. You know? It is kind of two different techniques, huh? Okay. Maybe we can prioritize the prioritization, huh? They're two different things, right? Okay, I have a couple experiments I want to run based on this locally. So far, this is almost at parity. We'll see if this ends up being any better or worse. Dropping the state of the start of each horizon. Yep, that's what I'm doing, Spencer. I guess we could experiment with, you know, if we wanted to randomize it or shake it up a little bit, we didn't want it aligned to chunks of 64, I could do a random state instead. I think all the states is just too damn many states. But no, actually, wait. No, there's a reason for this, Spencer. So the reason for this is because you have a solid advantage estimate of the first state, right? You have to compute an advantage estimate looking forward. That's why I did it that way. Because when we add stuff into the buffer, it gets prioritized based on the advantage estimate of it. Okay, so this looks like it's probably slightly worse by one maze. Oh, nope, never mind. It's going to be the same. One in X rollout Carls. I don't think it'll really help scaling that much, Spencer, either way. And the thing is, you don't know which ones that you actually need until you compute the advantage. And then there's also this whole bunch of estimation bias crap to correct, and that makes it harder. Well, 5 minutes for 45 scores. Pretty damn good. I wonder if it gets 47. I doubt it. Be cool, though. Nope, I haven't watched anything yet, Spencer. I'm pretty confident in this ENV overall. I have not watched it yet, though. Kind of thinking in algo space at the moment. I'm trying to think about the whole important sampling bias thing. Okay, we end on 45. Which is just as good as the other ones. But at the very least, it seems like the double priority thing doesn't hurt. Very clean progress curves as well. All right, here's the next thing I wanted to try, right? So I have this prio alpha, prio beta. This, I think you do need this for important sampling, right? I wonder if you need this beta, though. Like, do you really need... Or maybe it's the other way around. Hard to say. Go look at the biases in this paper. How they introduce their important sample thing. How do you confidently determine algorithmic performance from small changes unless you do a large sweep of params on training runs? We do a large sweep of params on training runs. That's how we do it. We run like 20,000 experiments. This is basically like, I'm fairly confident that the analysis I'm doing here is correct, but like I also have a sweep going in the background, and I'll launch another one tonight. You know, I have a sweep going for the baseline, and then we'll have a sweep set up for this environment. Oh, holy crap. Wait, we're at 45 score in a minute and a half. Huh? That was something. That answers that then. Yeah, Teddy, we run more RL experiments than anybody else. Have you seen Constellation? I'm super proud of this thing. This just runs in your browser, and this has data for all of our ends. All interactive, you can click it, you can filter it by all sorts of different values. It's super fast, it has all the data from Puffer 4 experiments. This is how we do stuff. Yeah, Puffer is just that fast. Well, I just guessed hypers, and then this thing solved in a minute and a half at 45. 47, I believe, Spencer. There's technically one more map it can get. It gets a reward after each stage, Arch. Reward after each, like, maze would probably just be impossible. I think that's impossible for almost anything. Okay, we're gonna try this one. I think that this is a better way to correct than the important sampling is. So we'll see. You guys get what I'm doing with this? So normally you would have this important sampling correction. We're going to set this to 0, and instead we're going to anneal the curriculum M so that we end up with 0 by the end of training. So we're going to end up basically having the train distribution end up the same as regular. There are a few ways that this could mess up. So I won't be surprised by any result here. Like, this could work and this could fail completely. I do hope we get a strong result one way or the other, though. I hope we don't end up at 43 or some bullshit. There are a couple more experiments we can run in here. This seems worse than before. I'll try this one. Because it occurs to me that we were annealing exploration beta before. We will watch this. Just to see. It is converging back, actually, to something better. The reason I want to watch this run is I want to see if it gets more unstable towards the end or something. It's having a very hard time here getting the 43. I wouldn't be surprised if that's because it no longer has enough ends. Oh, and now it just jumps to 45. Okay. Maybe I'm wrong. Let's see if it gets 47. I don't think it will, though. My prediction is that it gets unstable towards the end of training because it doesn't have enough curriculum ends. Of course the puffer is sentient. It's a pufferfish. They're quite friendly and intelligent. Oh, are we getting unstable? There's a little bit of entropy left. It could technically still solve it. But like right now, it has maybe 30% curriculum ends. X audio is delayed. If X audio is delayed, that is on X. What's the score based on? So this is the average size maze. This should be at least the average size maze that the agents are completing. So flat on 45 should mean that essentially all the agents are completing 45 by 45 and then failing on the 47 by 47. Ooh, that is a little bit of signal right there. There is actually a little bit of signal above 45. Oh. Huh. I have one more experiment to try after this as well. 47? Ho ho! Look at that, folks. That's solved. Up, and then score goes to 0. That's wonderful. Yeah, so this is, it going to 0 is what happens when you anneal, yeah, that's what happens when you anneal out the clip fraction. Or the CL frac. Alright, I'm gonna try this again without annealing the CL frac, and we're gonna see if this works. It got to 47 by 47, and then what happened there? So 47 by 47 is a really, really long set. Like, that's a really long set of M's. And it had basically no curriculum M's left either. It's basically running from scratch all the M's up to 47. So it did that, and then by the time it finishes the 47 by 47, it no longer knows how to do the earlier ends because it wasn't getting any early data. I mean, so this is pretty solid evidence that you don't want to anneal the CL frac. So then it's just a question of whether you anneal beta or not. It's all over the place. We'll go double check the logging real quick. Yeah, see, this is... Yep, that's fine. Removed all consumables, and it's sodaed. That's funny, John. I did something similar with Volo, and it didn't soda, but it basically did just as well on the Inferno with no supplies as with all supplies. So I kept, I think I kept the restores. Because I forget if you can actually prayer flick in our version of it. I don't think you can prayer flick. Like, one tick flick, I mean. How quickly you can do breakout? It's not going to be any faster, Jess, I don't think. I mean, we can try it, but, like, it's going to need to be retuned, and then this algorithm is not going to help every env. It might help breakout, actually. You know, come to think of it, it actually might help breakout. Alright, so regardless of whether this gets 47, this should be way more stable towards the end than the other run. We solve breakout in half of a second. That'd be fun. I wouldn't be surprised if all we need to do to solve this anyways is just increase the entropy a little bit. I want to see what this gets, though. One to two solves per second. That's fun. Well, your language model does 1 to 2 steps per second on breakout. We solve it 1 to 2 times per second. Yeah, that's great. Actually, hang on. I think this works, right? Uh, hmm. The important sampling is a little sketchy, actually, to be fair. I'm not sure. Oh, there you go. That's 47. That's 47 and 340. Like, yeah, that's perfect. Okay. Well, this is 47. I mean, that's fucking ridiculous, isn't it? The cool thing about this result, if you think about it, is we actually are not even going to need to wait for another sweep, right? Like, we don't even need to wait for another sweep. All we need to do is know if the baseline can get this in 4 minutes. Maze never maxed out. This is maxed. It only generates to 47. Spencer messages me like, I eat some chicken parm and you solve RL. What the fuck? We do have to eval this, but this should be better than like any of the other maze policies. I guess, of course, we still have to run this on. You know, why don't we just run this on the normal mazes just to see how well it does? I'm kind of curious. I mean, this learns a full determ policy, of course. It'd be even funnier if we made it like um every single maze ramps up. We'll keep the benchmark this way for now, though. It's over 9,000. Actually, let's just do real quick. I thought that we had a little script for this, didn't we? That's annoying. Oh, biggie. So we'll just delete this. And enable this. Now, if this soda's, like, we just win. Puffer 5 is ready. We ship it tomorrow. No, we don't quite ship it tomorrow, but, like, we literally could if we want to, if this works. What happened to my camera? Why am I all, like, fuzzy looking? Ooh, actually, let's try this end. We'll try both end coefs. Some random puffer art. Hey, look at this. That's a nice puffer. Ooh. We'll have patience with this one. And then we'll see with the entropy if this needs to be bumped for the new algo or not. Okay, it is training. It just took a while to get started. But that could be learning rate annealing. That could be many things. But we'll see how this does. It'll be interesting. I also have just arbitrarily set 80% of the environments to be curriculum M's at this point. That might not be the right number. Let's see how this does, though. $92. That was a really stupid stream, Jonathan. It's kind of unfortunate that's my most watched stream. I mean, it was intentionally stupid, but intentionally stupid is still stupid. The models have gotten better, and I don't remotely use them in the way that I, like, did for that dumb stream. So, better models combined with controlled usage is producing some nice results. And it's actually producing usable code, at least when I am very heavily monitoring and manually editing things. And the people saying I told you so a year ago, like, the models just sucked even worse a year ago. They're just bad programmers. Like, it's kind of funny in this case. The early adopters are just the really bad programmers because the earlier models were just, like, way better than they were at programming, which is kind of sad. The models are still bad at programming, but, like, they're quite quick and useful, and they don't make a lot of, like, basic syntax errors and or syntax and usage errors. They make more just, like, architecture and decision and implementation errors, which are that at that level I can very precisely describe what I need. Okay, I'm very curious to see how well this thing is going to do, though. It's very, very close to being on par with before. It's so close. And this is just me guessing the prio coefficient, basically. I think it's going to just be on par, not better. See from the eval. Yeah, it's just about the same. Well, we get to sweep this still, and this is not the end to test on. It's really not the end to test on, so that's not too disappointing. The fact that this doesn't make it worse, though, is good. I think I have headless rendering working. That's nice. Oh yeah, I'll summarize in a sec, Jess. Export frames into a folder, and I need to stitch them together. Wait, do you have to do that, Arch? I didn't think you have to do it that way. We have in the drive env already, like, you can pipe... I think you should just be able to pipe the output to FFmpeg directly, and have it be way faster than stitching. Beat me to it, Joseph? Yeah. So, Jess, so far today, we have implemented and refined the GoPuff algorithm, which combines Go Explore style state sets with prioritized experience replay, but over the starting states that you use. Fixed a whole bunch of problems with the algorithms, gotten it implemented correctly, at least for fixed numbers of agents in multi-agent environments. We have made a version of the maze env that is better suited to test this. We have very, very good results on that, which so far I have not seen any configuration of the 4.0 algorithm come anywhere close to. I'm currently checking what the sweep has produced on that so far, because we're doing that now. We've also refactored Puffer to use a single compilation unit instead of a C build and an NVCC build. NVIDIA, like a CUDA build. And that costs us maybe 2 to 3% perf, but lets us dramatically simplify a bunch of the really jank stuff in the code. And we should be able to optimize that back with some new things that we can do now that we have it this way as well. That's the summary so far. A lot of stuff. Whatever, this stupid script, we don't care. Oh, hang on. Maybe this thing has found something good. Okay, it did find something good, but it takes 16 minutes. And over 1 billion steps. Interesting, though, it did find something. It did find something. With probably a very big model, actually. Yeah, a giant model. Holy crap. So interesting that it is able to solve this task in 4.0 with a gigantic freaking model. Oh, but not fully solved, right? This is still not even, this is not 47. 193 experiments so far as well. Well, this will be interesting, right? We'll get to compare these two. I'm actually very surprised that we're able to do this at all with, that's crazy that that's actually able to do that with, Puffer 4. I mean, if you think about that, that's like a single example up to each maze size. Huh. How many unique mazes does it train on? I believe like 23 or 24, Ryan. It's a very small number. It basically, oh, did you just get here? I think we solved curriculum learning today. It has to solve a 5x5, then a 7x7, 9x9, so on and so forth. Okay, so odd sizes is fine. Press X to doubt. So Ryan, in 4 minutes, we are able to train an agent that will, in a row, solve 5x5, 7x7, da 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 da, all the way up to 47x47, which was the previous largest maze that we were training in the nicely randomized setting. We do have one version of Puffer. It looks to me like we have one run so far, from a 200 run sweep in Puffer 4 that is able to do it, but that one takes... Oh, it's actually not that many steps, but that one has a massive model. This is... How big is this model? It's like a 20 million plus parameter model. Can it mostly memorize? It's sparse, dude. It has to randomly, like, it only gets a reward at the end of each maze that it solves. And if it runs out of time on any individual maze, it gets sent all the way back to the start. So it's a 9,000 episode length task with only like 24-ish intermediate rewards. And it gets increasingly sparse the farther you get. Progressively memorizing. Right, but like if you do this from scratch, you won't ever solve a 47x47. Like you can run it for 1 billion steps and you just don't get the reward. Go Explore can solve that pretty quickly. No, it can't. You need a heuristic, right? Go Explore has Go Explore uses an archive as the heuristic, right? And they'll like downsample the maze or whatever, or they come up with or they'll use like XY. This doesn't have a domain specific heuristic at all. Not for mazes though. Where do you see the mazes for Go Explore? Your project. Oh, I see. Well, then wait, how are you getting any signal? One-to-one state to cell mapping? One-to-one state to cell mapping. Oh, wait, so you'd be deduping it then, right? So then you're exploiting the fact that there are only so many observations, right? Because otherwise with that, if you add a tiny amount of noise, then you just have massive blow up of states. I think this is still more general, man. This literally only uses advantage. That's basically what you're doing with a full state buffer. No, it's not. That's the thing. So what I'm doing is every so often you just take the current state and you stick it into a buffer. There's no deduping, there's no like assumption that obs corresponds to like there's none of that. The only metric that is being used to sample from that buffer is advantage. In fact, the states never even go onto the GPU. The states just say on the CPU. The only thing that you need the states for is to set the environment. Like, Algo never even directly sees the states. Isn't it randomly generating a maze every time? Not in this version of the task arch. We made a version of this task for state set exploration stuff. One-to-one state to cell mapping. That is interesting, though. That strategy is uniquely good for mazes. No. The thing that I'm doing is not uniquely good for mazes at all. Like, for instance, we want to throw this on, Valo has the Inferno sim, and John has the Fight Cave sim. Both of those are, like, you know, very long tasks. Fight Caves, maybe 40 minutes, Inferno, like, an hour and a half. And, you know, you have an unlimited number of states and observations, effectively, with those, and this will work. Well, you can't afford to search for... No, it's not. That's the thing, Ryan. It's not bad. Like, it doesn't have that problem. That's my point. Because you're not searching from every state, right? In fact, I've tested this, and this doesn't help at all if you use uniform sampling from the state buffer. The key to it is that you're using advantage as the metric for prio replay. You have a uniform buffer of states, like a ring buffer, but you're doing biased sampling in a fully general way. And it's also basically no performance overhead whatsoever. Actually, I wonder if the current version is performance overhead. Because I know it won't be if I optimize it. Let me see if I can do breakout. This probably won't solve breakout with default hypers. Yeah, so that is the key, Ryan. It only helps. So this is the one limitation, right? This solves a portion of exploration. I think it does solve curriculum learning in the sense that you're assuming like there is a curriculum, that there is a signal. The only remaining thing in exploration would be like state coverage. This does not solve state coverage on its own. So in a state like in an env that's purely based on state coverage, you could have no reward at all in the env and still want the agent to cover states. Exploration is hard. I hear you keep saying solving curriculum learning. Well, the thing is in my mind, so curriculum is you have like there's an ordering to things presented in some way with signal, right? I think exploration is broader than curriculum learning because exploration also includes state coverage. This doesn't solve state coverage. And the reason I would say that I think that this solves is because, like, state sets is just about the most powerful technique you can use, right? Like, you can provably show, like, there are problems that you just do not solve with anything that does not use state coverage in a reasonable amount of time. I mean, state sets in a reasonable amount of time. Curriculum learning is much broader than setting states, but I think that setting states is just about the most powerful technique you can use. Like, there are problems you can demonstrate that you cannot solve any way other than setting states in a reasonable amount of time. How would one even solve state coverage effectively? That's hard. I have some ideas, but I think that's going to be like an additional algorithm change. Okay, so this is original breakout. Oh yeah, Ryan, I also have a giant piplip if you want one. Very related. Tabula rasa, you need state sets. Yeah, but it really, in my mind, it's not, like, it doesn't matter that a human can solve those examples quickly. Like, having pattern recognition baked in, like, that doesn't help. How big? Oh, cool. 2 to 3 weeks. Yeah, I'll be around. How big? Like 2.5 feet, maybe tall. Couple feet wide. It's a chonker. It's free though. I gotta get rid of it, and I've been saving it for somebody who would appreciate it. I don't think I could take that on a plane. I mean, I'll ship it to you. Deal. Sounds good. And we'll see whether you think I've solved DL by then. I mean, like, even if I do, it is based on your lab's work, isn't it? So 9 months. Okay. Awesome. I have been thinking about this algorithm for quite a while, I will say. Like, this is not just I did this in a day. Like, this has been an algorithm. I sketched this out last week, but like I've been thinking about this algorithm for a long time. Oof. Okay. This hurts right here. This takes us down to 15 mil SPS. Presumably we can make this faster though. It's probably the sampling. Yeah, I actually, one thing I could experiment with, I'm using the absolute value of advantage right now. So you get like really good and really bad outcomes. It's inspired by the Gigaflow paper, where they do the sampling, and inspired by also like my own stuff on Puffer 3, where we did prioritized experience replay combined with this advantage filtering stuff. So I mean, this has been in the works for a while as well, in some sense. Right. They're all a tiny change from pure advantage. Yeah, I will have to ask you about that because I don't know anything about that area at all. Oh, you know what? I bet I know why this is slow. I bet you that if I do warm up, I bet you if I do like this, I bet you it immediately is fast. Okay, a little bit faster. So there's something stupid and slow in here. Okay, that does solve though. I don't think this improves stuff yet though. It doesn't improve stuff yet. In the original paper, it's abs of advantage or max of 0 and oh wait, is that literally what it is? Abs of advantage. I got that separately from Gigaflow. Max 0 and advantage. Hmm. Yeah, multi-agent is pushed, Jess. Okay. Yeah, current one I'm using should be abs of advantage, which is what also we use that for prioritized experience replay. Well, it's not exactly prioritized experience replay, but like the sampling thing we do with Puffer 3, we have that. What time is it? 5:30? About half an hour. Oh yeah, one other funny thing I'm doing, Ryan, is I'm intentionally not setting the RNG of the environment via state. So state is decoupled from RNG. So when you return to a state, like dynamics can be different from there. What's puffin'? uh Go explore research is puffin'. Oh man, you have to link me that non-clickable PDF/20 2010.03934. Page 5. Wait, 5. So wait, would you do... Which one of these? So I guess our version is closest to JE, right? But it's not actually JE, it's Puffer Advantage. JE is best on this one. Min margin. All averaged. Yeah, so JE is basically near the top here. They have one-step TD for some reason that's also good. We already have JE computed, so I think we can just use that. Puffer Advantage as well. L1 value is the best. Wait, no, isn't this the worst? L1 value is the worst, isn't it? Yeah, L1 value is the worst. And then... Wait, why do they have two plots with all averaged? Wait, what? Hang on. Now I'm confused. Why do they have their plots like this? Wait, one... PLR rank P... Wait, so JE is the best here, and then min margin is the best here. But, like, they don't give me an average over a bunch of ends with these, do they? These are very noisy. Like, look, it's completely different across two ends. Test them quickly. Fair enough. Well, we will be able to discuss if you're here in a couple weeks. Margarita's on me. Soul, Miss Soul. They basically should sell me a meal plan at this point, man. I'm doing a 1,000+ calorie cut at the moment, and it's basically I just eat soup. I just run and I eat soup. That's all I do. Membership card. What other ends can I test this on, you think? I guess, like, maybe 2048 would be a good env. I think 2048 would be a really good env for curriculum, right? Kinda soup, Mexican chicken soup. Yeah, I think, yeah, 2048, because you have to get through the whole damn game otherwise, right? Homemade? Of course it's homemade. I've been using mini-hack. Yeah. If we can port NetHack to actually be fast finally, then maybe. But, like, with 20 mil step per second training now, we're kind of just using our own ends. You know? These are the ones we have at the moment. We've got a few more ones we can merge. Yeah, I think of all of these, the only one that stands out to me as a really good candidate is 2048. Go is kind of too messy, and it's a self-play env. We will throw it on chess because we already have a way bigger active project on chess. 2048, though, I think is the next biggie. And this is really easy to do state sets on. Oh, that's you, Jess. So yeah, obviously we'll do on chess for you. I thought it was Ryan. You just mess with the reward function for someone, like make Pac-Man sparse. Um, eh, maybe. What do you think the main blockers are? Should be faster, refactor. I don't even know if you need to refactor the NetHack code base. You just need to get the, like, figure out what chunks of the Python bindings that are in NLE you actually need to make it work. What obs you actually really need, ideally flat obs if you can get away with them, like not gigantic obs, and then get it bound at the C level to Python's to Puffer's env API and see how fast it is from there. Like, that might actually be enough. I would very, very happily take a PR for that. Yeah, but the Go policy we have is like, eh. We'll give it a try. I look forward to seeing it. Yeah, I think if we can get the obs down to a reasonable enough size, it's a little tricky because it's these, like, the obs are glyphs. Honestly, I don't really think there's a problem with just using mazes for now, Ryan, for the research. Once I have this stable and I'm happy with it on mazes, I'm gonna test it on, like, we have the whole RuneScape Inferno. Like, that'll be a really good end. That thing takes more than an hour. And that's not mazes. That's like 61 increasingly difficult levels that you have to do in sequence. Yeah. I mean, this is the cool thing with the puffer ends, right? Like, we actually have some pretty heavy-hitting ends that we can use, and they're fast. RuneScape's very different. So the funny thing is, even with Puffer 4, we're kind of already mostly beating it. Um, Puffer 4 is quite good. I think it can do it much faster and with it, like, less hacking. Because we do have a couple, like, manual curriculum points in it at the moment. So I think we can probably do it without them. No more problems to solve. We will still have problems to solve, Ryan. Eventually, I'm just gonna, like, start doing low-level molecular sim or some shit. What resources used when I was a beginner to strengthen your RL concepts? I mostly used the resource of bashing my head against crap. Luckily, you can do better than that, and I've made a bunch of things to help. If you just go to my X and articles, these two articles right here are your best friend. And there are a bunch of other research articles there as well. Where is it? Log. Oops. But coupled with you trying to get a biochem degree in a year. I mean, I am kind of right by Stanford here. And, like, a year is so long, man. Why don't we just do it in the summer? That'd be a little tricky. You kind of have to take the intro course before you take the advanced course. You could probably do it in a year. Like, you can do CS in a year. Hell, I did CS in a year, right? At least the core of it. And some grad stuff. You can do it in a year. See you, Ryan. Mm, that's obnoxious. I don't know if you can do a fast sample without replacement, though. Okay, yep. So it's complicated. Little screwy. Hmm. Not sure about this. See, this is where we start adding a bunch of garbage very quickly if we're not careful. Okay, it is faster. I have to order some food on the side here. My normal place is closed on Mondays. Okay, it is done. See what this does. And we'll have a few M's for testing. 2048 is an interesting one because let me think. 2048 actually does make sense as an N. The spacing of the progression is quite aggressive though. Oh, it did find, look at this, it found a 47 solve. But it found a massive policy. Oh, this is not that bad though. This is 10 minutes. Yeah, it gets exponentially harder to solve, and it takes like twice as many moves, right? Because the weight, it gets double the size, so it takes twice as many moves. Whereas the mazes only take a few more moves to solve. It's quadratic number of moves. It's going to be very interesting to run the sweep versus this. Tired, man. I think we need this stupid state refresh thing. This looks good, right? The actual 47, I'll believe, will be a little volatile. Build in the meantime. Oh yeah, you can't name shit min and max. I don't know why you do this anyways. Fix that later. As is 45. Look at that. Prio alpha set to 1 in G2048. $13, not bad. Alright. Let's in the meantime Okay, we have this done. All I have to do is run an extra experiment or two on this. And after a certain number of runs here, we'll see how many runs I want to do on this. I guess, what's a good number to do? It's had 200 runs. I guess, like, before I go to sleep, maybe 300 runs. I'd really like to have the new one swept overnight. Tomorrow's agenda is Puffer 5 Dev. I'm going to basically mull over the results and think about what I want to do next. Follows going to be playing with it on Inferno tomorrow. You'll be playing with it on chess whenever you feel like. Latest stuff is all pushed. Fix any small things as you see them. Time is it? 6:07. I gotta head for dinner in a few. Think is there anything else I can do? I think that's kind of it. I think I just call it here, guys. And yeah, I think I just call it here. And we'll pick this back up tomorrow. Hey, Muffin. This is some very solid progress. I suppose we're gonna have to see based on the sweep. From what I've seen, though, so far, even though this thing is finding solves, it's finding, like, giant net slow solves. But I think there's still going to be massive, massive lift. Okay. For folks watching, thank you for joining in day one of the Puffer 5 Dev. If you'd like to support my work for absolutely free, star the Puffer on GitHub. Helps us out a lot. Join Discord to get involved. This is all open source, free work. And you can follow me on X for more reinforcement learning content. If you happen to be at a company doing RL and would like our assistance professionally in custom R&D or in simulation development, you can drop me an email.